The atmosphere is in continual motion with changing temperatures, air currents, and wind. The incoming solar radiation is the short waves that heats up the atmosphere and the Earth's surface. The interaction of the insolation with the atmosphere and the Earth's surface creates heat, which is measured in terms of temperature. While heat represents the molecular movement of particles comprising a substance, temperature is the measurement in degrees of how hot or cold a thing or a place is. Now let us learn the factors controlling temperature distribution. Basically, there are 5 in numbers. The first one is the latitude of the place. Second, the altitude of the place. Third, distance from the sea. The air mass circulation. Fourth, the presence of warm and cold ocean currents. Fifth is the local aspects. Latitude, we have already learnt. The temperature of a place depends on insolation received. And it has been explained earlier that insolation varies according to latitude. Hence, the temperature also varies. Next one is the altitude. We know that the temperature decreases with height because the density of air decreases with increasing height. When the atmosphere is heated by the sun, the lower layers get heated more than the upper layers. The reason is the density of air is high near the earth than at higher altitudes. The air actually becomes thin at higher altitudes. So there are less air molecules to trap the heat of the sun. That is why temperature decreases with increasing height. Now we have also learnt that the atmosphere is indirectly heated by terrestrial radiation. This heating is from below. So the place near the sea level record higher temperature than the place situated at higher elevation. In other words, temperature generally decreases with increasing height. The rate of decrease of temperature with height is termed as normal lapse rate. And the normal lapse rate is 6.5 degrees Celsius per 1000 meters. Next is the distance from the sea. This is another factor that influences the temperature of a location. And this is with respect to the sea. Now we know compared to land, the sea gets heated slowly and loses heat slowly. And on the other hand, the land gets heated up and cools down quickly. So during the daytime, at the land the temperature is high and the pressure is low. And at the sea the temperature is relatively low and the pressure is high. So the land close to the sea gets sea breeze, which is cool. During the night time, the land cools faster. So the land is cooler than the sea. So temperature is low, pressure is high, and wind moves from land towards sea during night. And this has a moderating influence of temperature in the coastal areas. But if we go in the interiors, this phenomena is absent. The land gets heated during daytime and nighttime it cools. So daytime it is very hot and nighttime it is relatively low. If I take Rajasthan, daytime summer the temperature may touch 50 degrees and in the night time the temperature will come down to 30 degrees or less. Next is the air mass and ocean currents. Like the land and sea breeze, the passage of air masses also affects the temperature. The place which comes under the influence of warm air masses will experience higher temperature, and the places that come under the influence of cold air masses will experience low temperature. Similarly, in the coastal areas, if warm currents like the Brazilian current is flowing, the coastal areas will be warm. And if cold currents are flowing like the Peruvian current, the coastal areas will be cold. You can learn more about the ocean currents from the video links that are given below. Then comes distribution of temperature. Now the global distribution of temperature can be well understood by studying the temperature distribution in January and July. The temperature distribution is generally shown on the map with the help of isotherms. So the lines that you're seeing are called isotherms. What are isotherms? Isotherms are lines joining places having same temperature. So supposing near the line it is written 20 degrees. It means the entire line region, the temperature will be 20 degrees and so on. Now when we look at this map, 9.4a and b, what do we learn? We learn that the effect of latitude on the temperature is quite clear on the map because the isotherms are generally parallel to the latitude. The deviation from this general trend is more pronounced in the month of January than in the month of July, especially in the northern hemisphere. In the northern hemisphere, the land surface area is much larger than in the southern hemisphere. Hence, the effect of land mass and the ocean currents are very clear. And we have seen that the variation in temperature is more on the land than on the water bodies. In January, the isotherms deviate to the north over the ocean and to the south over the continent. This can be seen on the North Atlantic Ocean. The presence of warm ocean currents, Gulf Stream, North Atlantic Drift, makes the Northern Atlantic Ocean warmer and the isotherms bend towards the north. Over the land, the temperature decreases sharply and the isotherms bend towards the south in Europe. It is much pronounced in the Siberian plain. The mean January temperature along 60 degree east longitude is minus 20 degrees Celsius, both at 80 degree north and 50 degree north latitudes. The mean monthly temperature for January is over 27 degrees in the equatorial oceans and over 24 degrees Celsius in the tropics and 2 degrees to 0 degrees in the middle latitudes, 18 degrees to 48 degrees in Eurasian continental interiors. The effect of the ocean is also very clear in the southern hemisphere. Here the isotherms are more or less parallel to the latitude and the variation in the temperature is more gradual than in the northern hemisphere. The isotherms of 20 degrees Celsius, 10 degrees Celsius, 0 degrees Celsius runs parallel to 35 degrees south, 45 degrees south and 60 degrees south latitudes. In July, the isotherms generally run parallel to the latitude. The equatorial oceans record warmer temperatures more than 27 degrees Celsius. Over the land, more than 30 degrees Celsius is noticed in the subtropical continental regions of Asia along the 30 degree north latitude. Along the 40 degree north runs the isotherms of 10 degrees Celsius and along the 40 degree south the temperatures is 10 degree Celsius. Figure 9.5 shows the range temperature between January and July. The highest range of temperature is more than 60 degrees Celsius. Over the northeastern part of Eurasian continent, this is due to continentality. And we have learned continentality is summers will be very hot, winters will be very cold, daytime will be hot and nighttime will be relatively cold. The least range of temperature, 3 degrees Celsius, is found between 20 degrees and 15 degrees north. Let us learn inversion of temperature. So here the rules of temperature are inverted. Normally we have learned that temperature decreases with increasing elevation. It is called normal lapse rate. At times the situations are reversed and the normal lapse rate is inverted, and this is called inversion of temperature. Inversion is usually of short duration but quite common. A long winter night with clear skies and still air is an ideal situation for inversion. The heat of the day is radiated off during the night, and by the early mornings the earth is cooler than the air above. Over the pole areas, temperature inversion is normally throughout the year. Surface inversion promotes stability in the lower layers of the atmosphere. The smoke and the dust particles get collected beneath the inversion layer and spread horizontally to fill the lower strata, that is lower layer of the atmosphere. Dense fogs in the morning are a common occurrence, especially during winter season. This inversion commonly lasts for a few hours until the sun comes up and begins to warm the earth. Inversion takes place in hills and mountains with a steep slope due to air drainage. Cold air at the hills and the mountains produced during night flows under the influence of gravity. Being heavy and dense, the cold air acts almost like water and moves down the slope to pile up deeply in pockets and valley bottoms, with warmer above. This is called air drainage. It protects plants from the frost damages. Thank you.